Okay, so this is table 10.1 on page 614. And so hopefully you read or you watched the video right before this one explaining kind of the big picture, the two parallel lines with the transversal line intersecting it, and the fact that it creates 8 angles. Continuing from that discussion, so notice these three pictures here. So we have two parallel lines, the transversal angle, right? Two parallel lines, transfer angle, two parallel lines, and transversal line. Is a transversal is a line. And the neat thing here is when we have these two parallel lines, right, and then intersected with a transversal, we create these 8 angles that I talked about. But more importantly, there's certain pairs of these angles have special names, right? But they also have special properties that are going to help us determine more angles. So one of the first ones is called, alternate interior angles, right? We have alternate exterior, right? Exterior meaning outside, interior meaning inside, and then corresponding angles. So notice the first description. I just make this a little bit bigger so I can really get in these angles. So interior angles that do not have a common vertex on alternate sides are of the transversal. So here are four angles. So the alternate interior angles, right, are inside, right? So if we have this big X, right, it's on the inside. This big X, it's on the inside. And so notice 3 and 6, right? These are these angles, the measurement of these angles are exactly the same. We can also use 4, right, and 5 if we want to. But I mean, they just used 3 and 6. So those are alternate interior angles. And so property, right, alternate interior angles, right, have the same measure. We just talked about that, right? They're equal. And one thing I want you to notice is here, okay, this is angle 3, and here there's an M, there's a measurement of angle 3. If you write an M, that means that you actually have a numerical value and you have an actual angle, right? 3 and 6 here, we're just saying that they're the same. We don't know exactly what measurement that is. That's when you officially find the M, the measurement. And let's see, similarly, right, we have alternate exterior angles or exterior angles. So the only difference, right, so we have the four angles, and so the 8 angles that we create. And here, angle 1 and angle 8, right, these angle pairs, they actually are the same angle. And notice they're on the outside, right, of the X, right? So if you think of this, that forms an X. This is the outside or exterior. And here's your other 2 lines, your X, and it's on the outside, right? So if you look at this diagram, here's your 1, right, and here is your 8. So exterior angles, right, and of course they have the same measure. Again, notice M measure, and you have an equal sign. And finally, you have corresponding angles. So corresponding angles is when we have an interior and an exterior angle on the same side of the transversal. Okay, so here it was all interior, here it was all exterior. So here this is interior and exterior. So notice that angle 5 here is interior angle. Angle 1 is an exterior angle, but they have the same measure, right? And then these are other pairs that really say the same thing, right? 2 and 6, right? Outside, inside are exterior angles, right? 3 and 7, 4 and 8, and of course we write it with an M, saying that the measurement of these angles have the same measure as their corresponding angles. So that's a little bit about table 10.1. We will be using it a lot in class, or you will be applying these properties to solve problems. So make sure you understand this, and if you don't, again, feel free to ask me in class and I can hopefully elaborate on that a little bit more.